Hey, and welcome to the part 7 in this video series about Echinoidea, a pavilion built in Milan in Italy 2022. In this tutorial I'm going to show you how to make family types with joints and then how to move the information from grasshopper to parameters in Revit families. And we will start with the joints that cut through the whole stick, and for that we will use column family type. We will use solid extrusion to make joints and then define parameters, and after that we will change the solid extrusion to void. And let's go to File, New, Family, English, Metric column, and change the depth to 100 instead of 600, and the width also to 100. Let's go to Create, Extrusion, take this rectangle tool, Finish, and let's go to the back view. By default the extrusion end is 250. Let's make it a little bit higher, that will be enough. And like the last time, we will connect this extrusion end to a parameter, and we called that parameter for the cutting length. Okay. And before we make the joints with extrusion solid, let's go to our Rhino and grasshopper files and see. I think that's these wraps that have joints that cut through the whole sticks. That's correct. Yeah, I can work on this side of the screen. Move this row 2 down. I'm going to need more space. And let's see, I need lines, and I have them here. And let's see, I will use cal index here as well. And I will copy this list, although we need to do some adjustments because the wraps indices do not correspond to line indices, so we need to do some adjustments. You are not going to exclude this line with index value 0. I think that's the last line. And then we will exclude instead this line. I think that's the line with the index number 39, 38, 37, 36. I have that one. 36, and this one is 35. I will exclude 35. And now I think I have all my lines for these wraps. Let's see, that's correct. Yes, that's correct. Let's go to Revit menu, go to Architecture and take column component. And let's make a group of these lines. Let's bring Scribble. And I will call this group for location lines. Group, and I will change the color to white. And now I have my lines, and the lines are the location of the sticks. And the type, I don't have the type yet, the new type. I have to save this one first. Save as family, and I will save it in my Revit families map columns. I call this one for stick 2. Save. Load into project, escape, let's see, families, columns, stick 2, it's loaded. And now go to the type, input value, and choose stick 2. And now I have my sticks imported in Revit, and I don't have any parameter. I didn't move the information about the length of the sticks yet. Let's do that. Go to element, element parameter, connect this column to the element. The name of the parameter is cutting length. Let's bring the yellow panel. Right, cutting length. And now I need the length of those lines, and let's see the information, how the information is stored. It's one group. All these lines are stored in one group, and we don't want that. We want those lines as individual objects. That's why we are going to graft this list. And now we have the lines as individual objects. Let's go to curve, analysis, length. Connect this list, this length component, and the information about the length of the lines to this value input. And now the length is correct. I will erase this green panel. And let's go back to our family type that we called stick 2 and make a joint that cuts through the whole stick. First I will sketch the joint with model line. Offset 100. I don't need 2 offsets. Trim a little bit. That's it. Now I have the sketch of my joint. And now go to create and do not choose void extrusion because you cannot define parameters on void extrusion. Go to extrusion and sketch the lines. Okay, and let's go to another view. Let's go to left view. We see that our extrusion is 250 and our joints are 20 millimeters deep. Change this extrusion end to 20. Let's go to the back view and now we will define parameters. Choose the extrusion, go to edit extrusion and define parameters. I need the position of the joint and then I need the angle of the joint. Let's see. It's not what I want. Let's try again. This line and this line. That's going to be my angle. And choose the position of the joint, go to create parameter. It's going to be shared parameter on instance level. Select, edit, and define a new parameter. We call this one L space 1. Common length, that's okay. Okay, choose L1, okay, okay again. And now we defined this L1 parameter. That's the one that defines the position of the joint. Let's choose the angle. Create parameter button, shared parameter, instance level, select, edit, new parameter. We call this one A1. And instead of length, we will have angle, okay, 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 and okay. And now we have these 2 parameters. I don't think that we are going to need more parameters. Actually, we need one more parameter or one more dimension, and that is the size of the stick is 100 millimeters, and we need to define that dimension. And actually, this is not going to be a parameter. We will just lock this dimension. So it's always going to be 100 millimeters wide. Okay, and that's it. Let's see here our parameters. Okay, load into project, overwrite the existing version. And let's see, we need to do one more thing. Let's go back to the family. Let's go to the 3D view. This joint is solid now. We need to change it to void and cut the geometry. Save and load into project again. And before we do that, I think I want to erase my model lines. Press tab. Now I can load it into project again. Now I have my joints, but the position of the joint and the length of the joints is not correct. Let's go to surface, deconstruct break, connect the list, this cow index list to prep input value, and let's read the information about the edges. Yellow panel again. Each prep has 23 plus 1, 24 edges. Erase this. Let's go to the list item, connect this list edges to the list input value, and let's take the slider. Since we have edges with the index number from 0 to 23, and now I want to find, turn this off so this prep will be more visible, and I will even turn off this column, and let's see. This is the edge with index value 0, index number 0. I need this edge and this edge. Those two edges define the position of the joint. And then I need even this edge, because this edge together with this edge defines the angle of the joint. So let's find those edges. I think this one is 11, in this value 11. I will replace slider with the panel. Let's find the next edge. That's this one, and I will replace the slider with the panel. I don't want to change the values, and I don't want the values to be changed accidentally. And let's find the last edge. We can take this one. Let's organize this a little bit, otherwise it's going to be too messy on the screen. Let's go to curve, length. This length plus this length defines the position of the joint. Let's go to Revit, element parameter. Connect the column to the element input value. The name of this parameter is L1. I write here L1. And the value is this length, or these lengths. Let's read them. Yeah, between 1384 to 1698, 1972, and so on. Connect them to the input value, and let's see what's going on the screen. And now the position is changed. That's okay. And the last, we need to move the information about the angle of the joints to this Revit family type. And let's read the angles. Angle is under vector. Angle, put it here, but that's the angle between this line and this line. And now let's take the element parameter component, connect this column to E input value. The name of the parameter is A1. Change it to A, change L to A, connect. And now we have A output value and R output value. And if we connect A output value, it stands for angles. Grasshopper reads radians, but you don't need to convert radians to angles. Don't do that. Just connect A output value to this V input value and it will be correct. Let's go to Revit and check the parameters for each stick. Make properties panel a little bit wider, and now we see this stick has an angle that is 39.05 degrees, cutting length is 2268, and the position of the joint is 1708.5 millimeters. Let's take the next stick. The angle of this stick is 40.31 degrees. Let's go to the next stick. The angle of this stick is 41.4. The next stick has an angle that is 42.35, and so on. Now we moved this big group to Revit. I make a group of this, and let's bring Scribble, and I call this one, let's see, column family stick 2. Column stick 2. Add to the group, and that's it. Don't forget that you cannot define parameters on extrusion void. You have to use solid define parameters, and when you are done, you change solid to void. Now we will make joints using sweep void, and we will go to the sticks with the joints where the joints do not cut through the whole stick, and that's these 4 joints, and we will start with these 2. Let's see, that's this one, it has own group, and this one, it also has own group. We will have one family type for both of these 2 sticks, but if we go to deconstruct wrap component, we can see that this wrap has 21 edges, and this wrap has 24 edges, so the information is not the same, so we cannot use the same information when we move information about the parameters from Grasshopper to Revit. That's why we needed to separate them. Actually, I will undo this. Let's start with this one, and here I need a line, location line, and my lines are here. I just need to extrude the line with the right position. Let's go to list item, and I need to find the right index. This is 39. I think this one is maybe 38. Let's check. 39 is the last one. Let's change it to 38. Yeah, that's that one. I will hide this item. So that's correct. That's the right line, location line. I will make a group and change the color of the group to white. And let's make a new family type. That one I'm going to call stick 3. First I will close this stick 2 family type. Now I have only my project file open. Let's go to File, New, Family, English, Metric column, and change the width. Let's see if we can change it here instead. 100, yeah. Go to Create, Extrusion, Rectangle tool. Press this green check button. Let's go to the back view. And here is our stick. We will make it a little bit higher so that we can place our joint. That will be fine. We will also connect the extrusion end to a parameter. New, shared parameter, instance level, select, cutting length. Okay. And let's save this family, save as family, and call it stick 3. Save. Here I will define one more plane, one more reference plane, and I will call this reference plane for joint. The distance between this new reference plane and the back reference plane is going to be 20 millimeters. That's the depth of our joints. Don't need this dimension anymore. Erase it, and let's go to the back view, and now I will sketch my joint. Let's see. And let's see, that's this joint and this one. Go to Create, to Revit, Model Line, something like this. And this should be 90 degrees to this line. Let's check the angle between those 2 lines, that's correct. And I will offset this line, 100. Now I will trim. This is my sketch. Let's go to Void and Void Sweep. And here it's really important that you use sketch path. Do not use big path, otherwise you're not going to be able to define parameters on the sweep void. Use sketch path. And now I will sketch my path. That's done. Check this green button. And now we need to select the profile, and first press here Modify Sweep, Now we can choose edit profile. If you don't press this modify sweep, this button will be grayed out. Do not forget to press this modify sweep. Go to edit profile. Let's see what I have. Open view. I need to sketch my profile first, so I will go out. So I will leave this. Quitting cannot be undone. Are you sure you want to discard sweep? Yes. Close this window. And now I want to sketch my profile. I will go to create model line, and before I start sketching, I want to change my work plane from back to joint. That's this one. Okay. And now I take my model line and sketch it. So it follows this line. And let's go to the 3D view, change it to wireframe, and now I have this line, and they will be part of my profile. I will change the work plane to back again. Okay, and now we choose void sweep, and as I said, don't use pick path, use sketch path. This is my path. Press this green check button. And now press this modify sweep. Now we can choose edit profile. If you don't press modify sweep here, then this edit profile button will be grayed out. Choose edit profile button, go to 3D view, open view, change to wireframe, and let's see. We use pick line to choose these lines that we already draw, and then we will draw 2 more lines here from end point to the end point, and 1 more from end point to the end point. And this is our profile. Press this green button, green check button, and green check button again. And let's see. This is our sweep. Now we want to define the parameters on the sweep void. Go to the back view, choose the sweep, and choose edit sweep. Choose the path, edit sketch. If you use pick path instead of sketch path, then you cannot use this edit sketch button. And dimensions, and I define the position of the joint and angle of the joint, and you define all the parameters for sweep void in relation to the sweep path. That's very important. Use sketch path, and then you set all the parameters in relation to the sweep path. I have my angle, and here we have 1 more parameter. That's this one, the length of the path. Let's see. Let's define that parameter as well. Choose this length. Go to create parameter, shared parameter, instance, select L1. Okay. Choose the angle. Go to create parameter, shared parameter, instance, select. It's already defined. We choose A1. Okay. And this one is not defined yet as a shared parameter. Go to create parameter, shared parameter, instance, select, edit, and new. And this one I'm going to call L joint 2. Okay, L joint 2, choose that one. Okay. And now I have this length of the path as a parameter in this family type, and I call it L joint 2 because I'm going to have L joint 1 as well in another family type. Press this green check button again, save, and load into project. Escape, and let's see. Let's go back to Rhino and Grasshopper and extract the information about the position of the joint, the length of the path, and the angle of the joint. Let's start with this first one. Go to Revit, add column component. The location is the line. Here's the line. Type is stick 3. Now we want element parameter. Let's copy the names of the parameters. And let's read the length of the line. Length See, the length is correct, but the position of the joint and the angle of the joint is not correct. Let's go to Revit and bring 3 more element parameter components. This one is going to be the position of the joint. This one is going to be the angle of the joint, and this one is going to be the length of the path. I need a new parameter name, call it L joint 2. And let's see. Now I need this edge plus this edge for the position of the joint. Let's turn this one off for a while. Set item slider, let's see, 21 edges. So slider is going to be values from 0 to 20. Okay, 0. Oh, I connected the faces. I need to connect the edges to this list item component. Okay, that's 11 in this number 11. $17. And one more. That's 14. That's it. And let's go to curves, analysis, length. This length plus this length. Math. And let's connect components to each other. And now we have the position of the joint. Now I see that I didn't erase the sketch lines. I will do that later. Let's see, what's this? I need this one for the angle, and this is the length of the path, but I need it even for the angle. Let's take length of the path. It's this one. Let's see. Now it's much shorter. And the angle, go to vectors, angle, that's the angle between this line and this line. So, and this line. And connect the components to each other. For the angle, we choose a output value. And now you see it's correct. And that's a lot of code for just one stick, but that's how it is. And let's see. I will group this one, Control G, copy this text, and I will call this one column family stick 3. Okay, add to the group. Let's erase first these sketch lines. Press tab button again, delete, save, and load into project. Overwrite. Now the sketch lines are gone, and let's go to the next rep. That's this one. I need a line here as well for the next rep. And let's see, that's only one line I need. I will use list item to extract that line. And let's see, this rep has index value 38, and I'm guessing this line has the index value 37. That's correct. This line belongs to this rep. And let's go to Revit, add column component. Location is the line, and type is stick 3. I will group this. Control G, change the color of the group to white. I will turn off this component for the moment so that I can find my edges. List item, and here I have 24 edges. I bring a slider down to the screen and change this one to 23. Okay, let's see, This is my edge with the index value 0. Let's find this edge and this edge and this edge. Those 3 edges. Let's start. 11 again. 16. And 21. That's those 3 edges we need in order to define parameters or move the information about the parameters from Grasshopper to Revit. Let's copy the name of the parameters and bring them down and go to Revit, element parameter. Copy this 3 more times. Let's start with the length, cutting length. Here is the line. Go to curve, analysis, length. Connect the line to the length and connect components to each other. Now I have the correct length. I need the length. I think I need it 2 more times. Let's see. Make some more space here. Math plus this edge plus this edge. I will rearrange a little bit here and connect the components to each other. Now I have the position of the joint. The position is right, but the angle is not right. So let's change that. And the length of the path is not right, so let's change that. This is the length of the path that we call L joint tool. This is the length, and now we need the angle. And let's go to vectors and angle. And the angle is between this line and this line. Connect components to each other. And now it's correct. Let's group this one as well. And actually it's going to have the same name as the previous group. And now we have only 2 more sticks to move from... I don't see my sticks now, but it doesn't matter. As I said, we have only 2 more sticks to move, and that stick is a little bit more complicated. We have to calculate the path. According to this sketch, I will explain why we need to calculate, and that I'm going to explain in a new video. I don't like long videos, and this video is already too long. That's all for now in this part 7. See you in the next part, part 8. Thank you for watching.